All right. So, cool. So what this is doing here, now we're going to practice solving for speed and velocity/velocity. We're more so going to solve for speed in this case because we don't necessarily always know the direction an object is moving. So let's read this. We've learned how to calculate acceleration to solve for force. Nice. We are one step closer to preparing for our egg drop experiment. For our experiment, the velocity will not be given to us. So we need to calculate that ourselves in order to solve for acceleration and force. To solve for velocity/speed, the equation is speed equals distance over time. It is also here, it is also here, it is in your reference sheet. We will use the term speed instead of velocity because we won't always know the direction the object is moving. The units for speed and velocity are the same, meters per second. Let's practice calculating speed today. Tomorrow we will calculate speed and then solve for acceleration. We need to know one for the other. So let's move on. What are we looking for here? Like, for example, here's number one. If a car travels 400 meters in 20 seconds, how fast is it going? Ooh, how fast is it going? So if we say how fast, keyword fast, what are we looking for? We are solving for speed. Yep, we're solving. Let's write speed. If you want to write velocity, we don't know the direction it's going, so speed is more accurate term here. What is given to us? Well, see here, let me see. We have 400 meters. So that is distance. Meters is how far something goes, so that's distance. And in 20 seconds, so that is time. And that's about all we got. So we are given distance. Let's call that D as 400. Make sure to write this down. And we are also given time, which is T, and that is 20 seconds. Beautiful. Okay, awesome. So what is the relationship? The relationship means, okay, we're looking for speed. So what relationship can we find here? Distance over time. I like to put D over T because it's helpful. So we'll just do distance over time like this. That is our relationship. That is our equation. So now let's solve. Okay, let us solve. Well, the first thing that we do is write out the equation. So speed equals distance over time. If you want to write it all out, you can, like the full word instead of a letter abbreviated. Now we're going to circle the distance and time values, which we've already done. And then we're going to plug the values into the formula. So we don't know speed, but we know distance, which is 400. Okay, sorry. Over time, which is, let me silence this guy, 20. Good. So go ahead and solve for speed. What is 400 divided by 20? Yep, hope you got that right. Some of you should have your calculators. It is actually 20. Cool, so am I done? No, you need to use the correct units. So the unit here is meters per second. Okay, meters per second. For this case, for this year, we're always going to use meters per second. We're not going to convert kilometers or anything, or miles or anything of that sort. So just meters per second. Easy on you. All right? See? That's easy. Why are we doing this? Because we need to know, like, guys, this is one of your velocities. This is actually the final velocity, VF here. It could be if you say, oh, it's going 20 meters per second north, right? This car is going north. In your egg drop experiment, things are going to go straight down. So they're going to go like downward. So it is going to have direction. So if it were to have a direction, then it would be your final velocity. If we have that, we can easily calculate acceleration. Beautiful. Okay, so other than that, you're just going to keep practicing solving for speed, solving for speed, solving for speed. And that's all you're going to do today. Okay, have fun.